Hello students, pleasant greetings to you all. Welcome back again to another video tutorial from the AP3X Institute of Mathematics Education. My name is Akin, your math instructor, and in today's video we're going to be looking at the City and Guilds Math Skill 3850 Diagnostic Test. Now this is the very first time that I'm actually doing contents related to math that is outside of the CSEC, SCA, CCSLC, and EDXL curriculum, but I am very much aware of City and Guilds and the kind of questions that they usually give to students. City and Guilds, in comparison to CSEC and other examination bodies, are a little bit simpler, but I do have students that do have challenges occasionally with approaching a City and Guilds paper. Math in general tends to drive a little fear into a lot of students, no matter how simple or how challenging it may be. So I was recently contacted by a student, a very good friend of mine, who is participating in a City and Guilds exam coming up in June, and they had asked me to do this video walking them through the diagnostic exam for City and Guilds. Now, of course, if this is the first time here on the channel, I'll be aiming to do more exam review papers in other examination bodies. Wherever it may be, please reach out to me in my DMs and I'll be sure to accommodate you as best as I can. So do not forget to hit the subscribe button below, turn on your post notification bell, leave some positive questions and comments, and do not forget to share this out to your math community. All right, now since this is the first time, I've not yet looked at the paper. I don't know what questions are going to come. I know that the questions are not going to be very challenging, but I'm going to try to give you the best approach towards solving these questions. All right, so hopefully this helps. Let's go through some of the instructions that are here. It says here that candidate's name should be printed here in block letters. Candidate's center name and number, the date, and the candidate's signature. So we have an hour to actually complete this paper. You should have the following for the examination: a pen with a black or blue ink, a ruler, a protractor. The use of a calculator is not permitted. Aha. So that's going to be key here. So you don't have a calculator, guys. So we're going to have to really depend a lot on our timetables and our fundamental concepts in math. This paper consists of 30 questions. Attempt to answer all questions. Your answers should be circled in the answer booklet. And this section here is obviously for the examiner. All right. So that's pretty much all the instructions that City and Guilds has given us here. So let's dive off right into the paper. So the very first question here states that 20 divided by, I'm assuming that this is an unknown variable, so they're using a diamond shape to represent the variable. Okay, as the same way in algebra you would use an x or an y to represent an unknown variable, and so 20 divided by some number is equal to 5. So well, I just looking at it, we'll know that the answer is in fact 4. But how to actually do this is, since we are dividing 20 by an unknown variable, then the opposite operation of division is multiplication. So we'd therefore go ahead then and say here, 20 divided by the diamond, or divided by 20, and that's going to be equal to 5 divided by 20. So therefore then the 20 would cancel the 20. So basically then the diamond here is going to be equal to 5 divided by 20, which is basically equal to 5 into itself one time, 5 into 24, so that's equal to a quarter. So what this means then is that if you take 20 and you multiply it by a quarter, your answer is going to be 5. Basically, multiplying by a quarter is the same thing as dividing by 4, because the reciprocal of 4, or the inverse of 4, is a quarter. So basically, even though we got a quarter for our answer here, 20 multiplied by 1 is really 20 all over 4. So technically, we are dividing by 4. So our answer there is A. All right, let's move on here, say, to example 2. Question number 2. Find the value for P if 1215, that's 1215, plus P is equal to 2430. So it's very similar to question 1, where we're going to have to use the opposite operation to remove the variable, or to remove the number, or the constant that is connected to our variable. So in this case here, because we are adding 1215 to the variable P, we're going to go ahead then and say 1215 minus 1215 plus P, and then that's going to be equal to the other side as well, 2430 minus 1215. We have to balance the equation by doing the same operation on both sides of the equation. So 1215 cancels 1215, and we end up with P here being equal to, now we don't have a calculator, so we've got to go back to the archaic days of doing math. So we're going to have to take here 5 from 0. We can borrow from the 3, leave 2, carry the 1. 5 from 10 is 5. 1 from 2 is 1. 2 from 4 is 2. And 1 from 2 is 1. So that's 1215. All right, so that is our answer here, D. All right, so that's one way of doing the question. Let's move on then to question 3. 6 fence posts are placed 5 meters apart. What is the distance from the first to the last post? Well, there are 6 posts. So between, let's zoom up here, between the first post and the second post is 5 meters. And so there's 1, that's 2 spaces, 3 spaces, 4 spaces, 5 spaces. So there's 5 spaces between the 6 posts. Therefore, we can simply say it's just 5 spaces multiplied by the distance of each space, which is therefore equal to 25, say here, meters. All right, so that's pretty easy there. Our answer is B. Now, how many of the same items can I buy with $4,815 if one of the item cost 15? So if one costs $15, okay? So for this question then, pretty much this is a very basic division question then. So I need to find out how many of this particular item, which value is 15, can I get from 4,815. So that's going to be 4,815 divided by 15. So we've got to go back to fundamentals, long division. Remember, we do not have a calculator. So we're going to go back. Hopefully you guys remember this technique that we learned back in primary school. So I'm going to go ahead here and divide here. Okay, so we're going to say how many times can 15 go into 48? We use the first 2, and that goes approximately 3 times. So that's 3 multiplied by 15. We're going to take the quotient here, multiply it by the divisor. So that's 45. And then we're going to do a subtraction here. So 5 from 8 is 3, and 4 from 4 is not. We can bring down the 1 again slowly. So 15 into 31 goes 2 times. So 2 times 15 is 30. And we go ahead and subtract. So 0 from 1 is 1, 3 from 3, not. Bring down the 5. And so 15 into 15 here goes 1 time. 1 times 15 is 15. And that's basically not. So therefore, the number at the top is our answer. So therefore, it is D. So this is just going back to basics. Remember, we do not have a calculator, guys. So we've got to go way back to when we were learning long division. Alright, so hopefully you guys got that. If it's a little bit too quick, feel free to just rewind that section of the video and just watch it again. Alright, next we have which is the smallest here. We have 9 times 6 or 8 times 7 or 5 times 11 or 4 times 1.5. So we're looking for the smallest. So we definitely have to have our timetable skills here. So I know right away that 9 times 6 is in fact 54. And 8 times 7, okay, so that's 9 times 6 is 54. And 8 times 7 is 56. So 8 times 7, 7 8s is 56. And then we're looking at 5 times 11, that's 55. You're pretty close. And then we have 40 multiplied by 1.5. Well, basically, multiplying by 1.5 is pretty much finding half of 40 and adding it to 40. So we know that 40 multiplied by 1 is already 40. So a half of 40, that is 20, and add it back to 40. So we end up with 60. That's another way of doing it mentally. Or you could just simply say 40 multiplied by and convert the 1.5 to an improper fraction. So that's going to be the denominator, which is 2, multiplied by the whole number, which is 1. So that's 2. 2 ones, 2, plus 1 is 3 over 2. So therefore, you can cancel 2 into itself 1 time, 2 into 40, say here 20. And so 20 times 3 is same thing here as 60. So whichever method you prefer, whichever skill set you have, you can utilize. So therefore, the last one here, 40 times 1.5 is equal to 60. So therefore, by logical reasoning here, you see here that 9 times 6 is in fact the smallest value here. All right. And you must, of course, know your timetable very well. Moving on next to question 6. And remember, we only have an hour, guys, so we may have to speed this up a little bit. Let's see if we can complete this within the 1 hour. Find the value of x if 36 divided by 3 take away 3 multiplied by 2 is equal to x. So pretty much what comes into play here is the principle of BOMDAS, or what I refer to as PEMDAS. So therefore then this rule here, PEMDAS, a lot of you guys are more familiar with, say here, BOMDAS, where we know that we're going to be working out what is in the bracket first, or say here the parentheses, followed by exponents, followed by multiplication or division, then addition or subtraction. So we have a parentheses here. We're going to just go ahead and rewrite the 36 divided by 3. And I'm going to work out what is in the parentheses here. So that's 3 times 2 is 6. And that's equal to, say here, x. Now again, I have division and subtraction. It obviously, that division appears before subtraction. So I'm going to go ahead and divide 36 divided by 3. That's going to be, say here, 12. And 12 take away 6 is equal to x. So 12 take away 6 is 6. So 6 is equal to x. So our answer here is A. Alright, so you must have good knowledge as it relates to the order of operations. I have a video on my channel as it relates to the order of operations. So feel free to check that out. I will pin a link to that video in the description box below. All right, moving on next then to question 7, 38 plus 115, and we want this answer here to the nearest 10, which is equal to, okay, so let's go ahead and write 115, and then we're gonna have 38 here. Let's just add these two. 8 plus 5 is 13, so that's 3, carry your 1. 3 plus 1 is 4, 4 plus 1 is 5, and so therefore we have 1 here. So now the number that we're looking at here is 153, but the question specifically stated that they want it to the nearest 10. All right, so we know that the 1 represents 100, the 5 represents 5 tens. So we're going to go ahead here and border off the 5 here, and we're going to identify whether or not this digit is less than 5 or if it's greater than or equal to 5. So since the 3 is less than 5, we're just going to simply replace the 3 with a 0. So therefore the correct answer here is going to be 150. Now if the 3, or if it was an other number like say 6 or 7, 8 or 9 or even 5, then we would increase the 5 to 6, so the answer would have been 160 as opposed to 150. Now many students can get caught here because after adding these two numbers, notice that the answer that you got is exactly there to catch you, but you must pay attention to this section here that says to the nearest 10. So therefore then the answer is in fact B. All right, so you've got to read these questions. What I notice about City and Guilds exams, and this is the first time that I'm actually doing a paper, never yet done a paper. I've always just heard about the exam body, but I've never actually done a paper. It really does help that you have to read questions carefully. All right, don't be too rushed to answer the questions. So let's, as you prepare for your exam, guys, read the questions carefully. All right, so here last week 1,500 fans attended the baseball match. This week 6 times as many bought tickets, but due to the bad weather condition, 250 fans have cancelled their ticket. How many are attending this week? So let's lay out some stuff here. So we know that last week we know that there were 1,500 fans, okay, but this week 6 times as many. So this week it was 6 times as what was from last week, so that's 6 times 1,500. Okay, so again here 1,500. Remember, we don't have a calculator, and I must do the paper as it relates to someone who may not be very strong with your timetable. You need to be, but depending on who you are and how long you've done math before, you have to have many methods of going around this. So 6 times 1,500, 6 times 0, 0, 6 times 0, 0, 6 times 5 is 30, 0 carry your 3, and 6 times 1 is 6, plus 3 is 9, so that's 9,000. So now we have 9,000 fans that is expected to, we have 9,000 fans that bought tickets. However though, the bad condition, 250 fans have cancelled their ticket. So therefore, cancelling means that they're not coming to the baseball match. So that's 9,000 minus 250. And so we go ahead here and say 0 from 0, 0, 5 from 0. We can't, so we go all the way over to the 9 here to borrow 1, leaving 8. Add it here, borrow from the 10, leave 9, add it here. 5 from 10 is 5, 2 from 9 is 7, and that is 8. Again, guys, remember, we have to use a lot of foundation math skills. Now, if you know how to calculate mentally, then you won't have to go through this process here of doing long addition, long subtraction, long multiplication. If you know, then you can just go ahead and circle your answer. But this is primarily for the student who may have a bit of challenge when it comes to fundamental math. All right, let's move on then, say here to question 9. All right, we're 20 minutes in. We have 30 minutes, so we got to get a kick on, guys. What is the value of the 2 in the number 5,328,475? Now, particularly, I know it can't be a million because I know already that 5 represents the million. So I know that by process of elimination, it can't be a million. Okay, we're looking at the 2, which is here. So it's 328,000. So 328,000. Okay, so we know it can't be 100. Okay, because 100 would be represented by the 4. So process of elimination, we've eliminated the 100. So it can't be 1,000 because the 8 here would represent the 1,000. So the 2 is going to represent 2 10,000, which is 20,000. So it's 328,000. So the 2 is going to represent 10,000 because 2 multiplied by 10,000 is going to be 20,000 plus the 8,000. That gives us the 28,000 that we're looking at the end here. Okay, so for these type of question, I tend to use more logical thinking. There is actually a table. I think what I don't remember what they call. I think it's called I don't remember what the name is. I learned it way back many years ago. There's a name for it where you have like a table that you have 100, tens, ones, units, 10,000s, hundreds, thousands. You know that table? Yeah, I don't remember what the name of that table is, but because I don't teach fundamental math, but I do remember doing something like that back in prep school. But nevertheless, here we can logically work that out. So our answer here is going to be 10,000. All right, now moving on to question 10 here. A worker's ID number consisted of 5 digits with 9 in the 10,000s place. Oh, okay, this one is tricky. 9 in the 10,000s place, 0 in the ones place, 8 in the thousands place, 4 in the tens place, and 2 in the hundreds place. So this now requires you to actually know the table that I was referring to moments ago. So let us see if we can draw up this table here. We know that the last line here is usually called your units table, and before the units you have, well, we call the units table your ones table. So it's gonna be something like, say, let's start at 1,000. So that's 1,000, 100, tens. Okay, let's start here. Let's make it a little bit better. Okay, let's draw up some table here. You must remember this when you were back in prep school. Okay, so you'd have something like, say here, you'd have something like, say, 10,000s, then you'd have 1,000, then you'd have hundreds, then you'd have tens, then you'd have the units or the ones place. All right, so I know that that's how the table. And then before you have 10,000, then you'd have 100,000s. Okay, so just before that you'd have the HT, that's 100,000. So 100,000s, 10,000s, thousands, hundreds, tens, and ones. Okay, so it says that the 9 is in the 10,000s place, so the 9 would have been here, and then the 0 is in the ones place, so that's going to be here. The 8 is in the thousands place. Okay, so no, the 9 is in the 10,000s place here, so the 9 is here instead, and then the 8 is in the say here thousands place, and so therefore the 4 is in the tens place, and then the 2 is in the hundreds place. There. So once you are familiar with the table, right, once you're familiar with the table, then you can easily put the number in the position that they belong. So what we're looking for is the ID number 98240. So that's 98240. That's going to be C here. All right, so pretty good. Next, then we're going to be moving on then to which of the following numbers represents 55,055. So 55,055. So we could actually use the table again if you want to. So we're going to have, let's see there, we're going to have 10,000s. So 10,000s, thousands. Then we're going to have hundreds, tens, and ones. Okay, so 55,000, and so 0 hundreds and 55. So that's 5 tens and 5 ones. So 5 10,000s. Okay, so that's, let's just break it down here. We have 5 times 10,000s. So put one of the 5 from the 55 in the 10,000s line. So 5 times 10,000 gives us 50,000. And then the other 5 from the 55 gives us 5,000. So 5 times 1,000. That's going to give us 5,000. So that's what gives us the 55,000. Then it didn't say anything about any hundreds, so we're assuming that this is going to be 0 times 100's place. So that's 0. And then obviously we're going to have 55. So that's going to be 5 tens. So that's 5 tens, that's 50. And then 5 ones, that's 5 times 1, that's 5. So if you were to add 50,000 plus 5,000 plus 0 100 plus 50 plus 5 ones, you get 55,555. All right, and again, you don't necessarily have to do it this way. If you know what 55,000 and 55 looks like, then by all means go ahead and type off in. Okay, all right, and we're going to be moving on to question 12 here. So we have a woman bought some hair products for her salon. The total cost of the products was $185.75. How would she write this amount correctly in words? So it's going to be 185. Let's just read here. Okay, so this statement here is saying 185.75. That doesn't sound too right. 185. That doesn't sound too correct. Let's have a look at the other one. 185.75. Sounds almost correct. Let's continue reading. $185.57. That doesn't sound too right either. So let's just eliminate that. $185.75. Okay, so I'm guessing that the answer is between B and D. Let's go ahead and read, because as I said, City and Guilds questions are very tricky. So $185.75. Sounds more like B is the answer to me. Okay, so I know that this is wrong. $185.75. I think there's an and that needs to be after the word point. So it's $185.75. Okay, I think that most likely the answer would be $185.75. I think that's the answer, guys. That's how you normally say it if you're reading out the money, $185.75. It's naturally how you'd write it out, or how you would say it if you see it on the, if you see the tag on a particular product that is for sale, you'd see that the price is $185.75. You wouldn't just say 0.75 cents. So this kind of sounds a little bit off. I'm just gonna jump out and say that the answer is B here. All right, let's move on. Let's kick it along, guys. How many pounds of flour is required to make 7 cakes if 1 cake takes 1.5 pounds? So let's go again. Tricky questions, guys. You've got to read carefully. You can't be too quick, guys. So we're looking at question 13. How many pounds of flour is required to make 7 cakes if 1 cake takes 1.5 pounds? All right. So this is pretty easy. We can go ahead here and say that, say here, 1 cake, we know based on the information, is equal to 1.5. So we therefore know that can convert this 1.5 here. 2 times 1 is 2 plus 1 is 3 over 2. So just converting this mixed fraction here to an improper, we know that 1 cake basically weighs 3 over 2 pounds, and we need 7 of those. So that's going to be 7 multiplied by, say here, 3 over 2. Now there's nothing to cancel out here, so that's going to be 7 multiplied by 3 is 21 divided by, say here, 2. And so there's this value is not there, so we have to convert it back to a mixed fraction. So that's going to be 2. How many times can 2 go into 21? Well, we can get approximately 10 times, and it will leave a remainder of 1, and we're going to put that back over the denominator, which is 2. So our answer here is 10.5, which is A. All right, guys, we have about 25 minutes to go. All right, so here we go. How long does a 220-mile trip take moving at 50 miles per hour? All right, so how long? We must be familiar with the distance formula. All right, if you're not familiar with the distance formula, we need to get familiar with the distance formula. Distance is equal to speed times time. Okay, distance is equal to speed times time. I think normally what you're going to find is that a lot of persons will always start off with the fact that speed is equal to distance divided by time. Okay, so how far you travel and how long you take to travel that distance will determine your speed. Now let's go ahead and do some substitution here. It says how long does a 220-mile trip? So 220 mile, meaning that that's the distance here. 220, and they're asking for how long, so we know that the t is the unknown variable here, so let's put a question mark here, and it's moving at 50 miles per hour, so that's going to be 50 here underneath the letter S. So 50 represents the speed, 220 represents the distance, and we're looking for the time. Let's just use t to represent the time. So what we can do here is that we can multiply both sides by t, or we can do a little swap. The shortcut for this is we can do a little swap. We can put the t up here and we can put the 50 back. We can swap the position of the t and the 50. Okay, so we could shortcut here would be to say here, put the t up top here and put the 50 at the bottom, so that's 220 divided by, say here, 50. All right, and so of course we can go ahead and cancel out. So we can cancel the 0 with the 0 here, and 5 goes into 22. Let's see, 5 plus 5 is 10, plus 5 is 15, plus 5 is 20. So it goes about 4 times, and it's going to remainder 2 over 5. So already we know that the answer is C here, 4 2/5 of an hour. Now, an alternative approach to this, a more algebraic approach to this, would have been obviously to say here 50 is equal to say here 220 over t. So we could cross multiply here, and we could say 50 times t is 50t, and that's equal to 220. So therefore, we can split the product here by dividing both sides by 50. Remember, 50 is the variable, is the constant that we don't want. So we're going to divide both sides by 50. So that's going to be 50t divided by 50 is equal to 220 divided by 50. So therefore, the 50 cancels the 50. Therefore, t then is going to be equal to, so t then is going to be equal to 220 divided by 50, which we just had worked out to be 4 2/5. All right, so it kind of really depends on the approach. It kind of depends on your knowledge base, what method you're most comfortable with. But both methods, as you can see there, gives us the same result. All right, remember guys that the purpose of this video is not necessary to finish the paper within an hour. Obviously, if I was doing the paper without teaching, I would have wrapped this up in about 40 minutes or so. But I want to make sure that as I go through the paper, you guys are getting the hang of how to actually answer these questions on your own. So question 15 here. 3 4/5 as a decimal number can be written as. Now, this is one of my favorite fundamentals topic to teach. Okay, so 3 4/5. So pretty much I know that it's going to be, the answer is going to be 3 point something. So I need to therefore take that 4/5 here and convert it to a decimal. And how we basically convert a fraction to a decimal is pretty much by long division. And if you know what the answer is, obviously I'm looking at the answer is D, but how many students are going to know that 4/5 is 0.8? Not many. So therefore then we know it's going to be 3 point, and we're going to go ahead here. It's going to be 3 plus the value that I'm going to get over here. So 4/5, meaning that I'm dividing, say here, 4 by 5. Okay, so I know it's going to be 3. And I'm going to try to figure out what goes here. So I know that 5 goes into 4 0 times. Okay. So 5 goes into 4 0 times. And that's 0. 0 times 5 is obviously 0. So I'm just going to, so once 5, so 5 into 4 goes 0 times. I'm just going to add a point right here. And I'm going to add a 0. And then say 5 into 40, 8. Okay, let's do that again, guys. First, we say 5 into 4. Obviously, that can't. So we put a 0. We put a point. Then we add a 0. Then we say 5 into 40. Say here, 8 times. So we're going to add 0.8 to 3. And then you're going to end up, say here, equally to 3.8. If you want to put the 0 is like a insignificant value there. It's just a placeholder. So it's 3.8 or 3.80 there. All right, but if you know what 4/5 is, 1/5 is 0.2, 2/5 is 0.4, 3/5 is 0.6, 4/5 is 0.8, and obviously 5 out of 5 is 1. All right, beautiful. Next question: if 30 students took an exam and 10 of them fail, approximately what % of them passed? And you can see that they highlighted this. A lot of students, this will fly over their heads. They'll most likely be reading the question and not paying very close attention to certain highlighted words. Whenever CSEC, SEA, CCSLC, or EDXL exams, or even City and Guilds, as you're seeing here, highlights certain word, you must pay very close attention. So we know that there's 2 ways to look at it. You can find out how many of them actually passed and subtract it from 100. Let's take it from that approach. So we know that 10 out of 30 students actually failed the exam. So that's 10 out of 30 times 100. All right, we can do some cancellation here. So that's going to be 0, cancel, say here 0. And then so we'd end up with, say here, 10 times 10 is 100 divided by 3. Now remember, we don't have a calculator, so how do we actually work this when a student doesn't know what is 100 divided by 3? You could probably make an educated guess and know that the answer is 33. So here we know then that 100 divided by 3, we can go on our long division table here. So 100 divided by 3, we can try 3 into 1, 3 into 10, that goes 3 times. 3 times 3 is 9. Remember here is 1. Bring down the 0. 3 into 10, 3. 3 times 3 is 9. And then obviously you're going to have a point here because there's no more number. And then it's going to continue repeating itself. 3 into 10 goes 3. You're going to have a recurring decimal here. So let me just remove this 100 here divided by 3. So that's 100 divided by 3. And if we continue dividing 3 into 10, it's going to continue with a 3, 3, 3. So we just pretty much put a little dot here and see that the number is recurring. So 33.333333 is pretty much 33%. So this pretty much represents how many that failed. 33% failed. But the question says approximately what percent of them passed. So we know that 100% of the students did the exam. So therefore then it's 100 minus, say here, 33. And that's going to be, well, 33.33 is going to be, you know, more or less, say here 34. So okay, so it's going to be, say here 67%, and the closest number here to 67 would have been 66. So rounding this off, you get about 66% of them that actually passed the exam. An alternative approach to this is, as opposed to finding out how many failed, we could just go ahead and find out how many passed. We know that 10 failed, so we know that 20 passed. So that's 20 divided by 30, and that's going to be multiplied by 100. Okay, so we could go ahead then and cancel, say here 0, cancel 0. All right, so we end up with 20 times 10, so that's going to be 200 divided by, say here 3. You go through the same approach here, 200. So 3 into 20, that goes 6 times. 6 times 3 is 18. Bring down the 2 here, bring down the 0. 3 into 20, 6 times. 6 times 3 is 18. Again, you can see that 2, we're going to keep carrying it down, put a point here. Okay, so it's going to be 66 and 2/3, which pretty much rounds off to about 66. So a couple of different approaches to it. Most of these questions are, if you're strong fundamentally in math, then you're going to realize exactly that 2/3 is 0.6, 1/3 is 0.3, so on and so forth. All right, 15 minutes to go, guys. 14 questions left. Let's see if we can at least try to beat the clock. If 1,000 meters equal 1 kilometer, then 3.725 kilometers is the same as, okay, so 1,000 meter equals 1 kilometer. Then we have 3.725. So that's going to be, we have this amount of distance to cover. Okay, and we know that 1 kilometer is equal to 1,000. Okay, so that's going to be 3.725 multiplied by 1,000. Now, the easy way to do this is just to pay attention to how many zeros are behind the 1, and then we'd go ahead and just jump that amount of place. So that's 1, 2, 3. So the point goes behind the 5. Therefore, the new number is 3.725 meters. And so your answer here is going to be, say here, D. All right, beautiful. All right, so easy way to go ahead and do just that. If it was 2 zeros, you jump 2 places. If it was 1 0, you'd jump 1 place. Okay, a man rented a lawn mower from 9 a.m. in the morning until 4 p.m. and is paid $288 and paid $288.40. What was the rental cost per hour? All right, so not too bad. very basic here. Just find out the time that comes between 9 a.m. and 4. I think there's a mathematical way to calculate time. I think that was one of the only math that I didn't learn, or I didn't get a hang of back in prep school. But I'm just going to use the traditional approach of checking the time. Let's see that we started at 0900 hours in the morning. So we know that between 9 and 10 is an hour. Let's continue with the clock. Well, let's draw a clock here. Okay, easy way to do this. Let's draw a clock. Okay, this is 9 a.m. Okay, this is 9 a.m. in the morning. So we know that 1 hour, that's 10. 2 hour, that's 11. 3 hour, that's 12. 1 o'clock, that's 4 hours. So that's okay. So this is 1 hour, 2 hour, 3 hour, 4 hour, 5 hour, 6 hour, 7 hour. So this is 4 o'clock here. Okay, so 1 hour, 2 hour, 3 hour, 4 hour, 5 hour, 6 hour, 7 hour. The man basically rented the lawnmower for 7 hours. Now basically, since he paid $288.40 for the whole 7 hours, to find out how much was he paying per hour, we divide this by 7. Again, guys, we don't have a calculator. We could make an educated guess as to what the answer is. I know that 7, I know right away, if I'm to make an educated guess, it's going to be 7 multiplied by 40 something, because 7 fours is 28. So I know that right away that this cannot be my answer. This cannot be my answer. This cannot be my answer. My answer most likely is going to be 41.20. And how I know this is that 7 times 40 already is 280, and I have some change left over. So I know right away it's going to have to be 41.20. But of course, let's not guess. Let's go ahead and go back to our fundamentals here. So that's going to be 288.40, and we're going to divide that then by say here 7. Okay, 7 hours. So 7 into 28 goes 4. So we know that we're just going to move on then and say 7 into 28 goes 4. So there's no remainder. So we just go ahead and then say 7 into 8 goes 1 time. 1 times 7 is 7. Okay, so that's going to remain a 1 here. Put a point, bring down the 4. 7 into 14 goes 2 times. 2 times 7 is 14. So that's not, and bring down the 0, not. So that's 41.2, which from a money perspective, it's 41.20. So you could educate it, you could guess this from an education perspective, just kind of common sense out the math problem here and figure it out. All right, beautiful. Moving on, guys, we have 10 minutes, 11 questions. Let's see if we can do a question per minute. The measure of how hot, warm, or cold a body is called its, okay, well, if you know, you know. If you don't know, you don't know. Mass measures weight. Feelings measures emotions. Area, well, obviously, how hot or cold something is your temperature. So let's move on then to the next question. How many degrees would the hour hand move in 4 hours? Now, this is actually, we know that a clock is a circle. And a circle basically measures a complete degree of 360 degrees. All right, so if you know, you know. If you don't know, well, you just learned. So a whole entire circle measures 360 degrees, and we know that from here it's 12, and right around the clock is 12 hours. So basically then, if you go ahead and divide this 360 by 12, you're going to find that here that each hour represents a degree of 30. 360 divided by 12 is 30. Again, you can use long division to figure that out, or you can just, pretty much know that 3 multiplied by 12 is 36 with a 0. All right, so we know that each hour that the clock moves in reality is 30 degrees. So therefore, in 4 hours it would move 4 times 30. So this angle right here would approximately be, say here, 120 degrees. All right, pretty good. So that's going to be, say here, B. All right, let's move on. All right, so a painter needs 3/4 liters of thinner to complete a job. At the hardware, thinner is sold in the following size. Bottle 1 is 25 cents a liter. Bottle 2 is 50 cents a liter. Bottle 3 is 75 cents a liter. And bottle 4 is $1 per liter. Which of the bottles would give him just enough thinner to complete the job? So a painter needs 3/4 liter. I don't think this represents money. I think it just represents them. Okay, so this is not actually 25 cents a liter. I think it's just 0.25 liters, 0.50 liters, 0.35 liters, and 1 liter. Okay, so this is a liter bottle at 3/4. So 0.75. If you check out 0.75, this bottle will give him some overs. But they want which bottle would give him just enough thinner. Normally, if you're gonna do a job, you don't want to have the exact amount, because what if one spills? What if some spills? So I'm going to. It's tricky. I think the answer is really B3, bottle 3, because bottle 3 is the exact amount. Might we look into this from a theoretic perspective? We always want to have more than the amount. Let's read it again. It says, which of the bottles would give him just enough? So they don't want any overs. So I'm going to go out on a limb here, and I'm going to say that the answer is going to be, say here, bottle 3, because this is just enough. 0.75 liters is really 0.75 multiplied by 100. Okay, so if you multiply 0.75 by 100, you're going to get it to be a whole number. So that's going to be 75, and if you divide it by 100 and turn it into a fraction, then 25 into this goes 3 times, and 25 into 100 goes 4 times. So right away we see that we get the 3/4 here that we're looking for here. All right, so just enough would have been bottle 3. A little bit more than that would have been bottle 4, obviously. Okay, 22. 5 friends decided to buy identical bags for school. Each bag cost $1,406. What was the total price of the bags? So that's just going to be 5 bags multiplied by $1,406. So that's 1,406 multiplied by 5. 5 6 is 30. So 5 times 6 is 30. 0. Carry 3. 5 times 0 is 0. Brings down the 3. 5 times 4 is 20. 5 4 is 20. 0. Carry 2. 5 1 is 5 and 2 is 7. So that's $7,030. That's C. All right. What should be the height of the rectangular block? What should be the height of a rectangular block with a volume of 96 square centimeters if the length is 8 and the width is 4? Let's draw a rectangular block. Okay, a rectangular block is different from a rectangle. So we're looking at here is, say here, this particular type of prism. So a rectangular block is really a cuboid. So that's a rectangular block. And they're saying that they're asking for if the height is 8. So we know that the height here is 8 and the width is 4. So okay, it says what should be the height. Okay, so we don't know the height, so let's call that X. Of the rectangular block with a volume of 96, if the length is 8, so the length is 8 and the width is 4. Okay, all right, so the width here is from here to here, and the length is from here to here. So therefore then we're looking at volume is equal to the area times height. So the area of a rectangle is length times width times height, and that's equal to volume, breaking down the formula. So therefore then we know that the volume is 96, so we can put the 96 underneath the V, and the length is 8 and the width is 4 and the height is still unknown. Let's bring this here. We're then looking at 96 is equal to 8 times 4 is 32 times each. And earlier, the very first question, we learned how to split the product. So it's going to be 96 divided by 32 on the left side, and on the right side, you divide by 32 so that the 32 cancels. So h is equal to, say here, 96 divided by 32 is 3. Okay, so the height here is 3. All right, so pretty good there, guys. Triangle ABC is a right angle triangle. What is the measure of the angle B? What is the measure of the angle B if angle C is 42? Now, we have to recall the internal angle theorem of any triangle. All three internal angles of a triangle measures 180 degrees. So this angle here plus this angle plus this angle will always add up to 180 degrees. So therefore, let's just call this angle here X, because we don't know what it is, but we know that whatever that angle is plus 42 plus this little box in the corner always represents an angle of 90 degrees. So that's going to be equal to 180 degrees. So therefore then X plus 90 plus 42, when we add that together in your own way, you're going to get 132 degrees. That's equal to 180. So therefore then we can isolate the X simply by subtracting 32 from both sides. So that's 132 minus 32 that is on the left, and that's 180 minus 132 on the right. So that 132 cancels 132. X is equal to, say here, 48 degrees. All right, so this angle here would have been, say here, 48 degrees. All right, beautiful. So that's the size of that angle. Alternatively, if you know that in a right angle triangle, the internal opposite angles to the 90 degree are complementary. If you know that complementary angles equals 90 degrees, then therefore easily an alternative approach would have been to just subtract 42 from 90, and you would have also gotten 48. That is if you know the particular theorem then. Okay. Question 25, we are just at the hour mark now, guys. However, remember, as I told you, the aim of this video was never to try to do it under an hour. It was try to make certain that you guys have an understanding of how to approach these questions when you get them. All right, next one here. The school bus usually arrives at 6:45 a.m. On Monday morning, it was 20 minutes late. At what time did it finally arrive? So pretty much here, from at 6:45 in the morning, we know that that is 15 minutes to the hour. So that's 15 minutes to 7, okay, to 7 in the morning. But it arrived 20 minutes late, so it would have arrived 5 minutes beyond 7 o'clock. So mathematically speaking, we're looking at seeing here, like I said, I don't know the time calculations. I remember seeing it when I was back in prep school way many years ago, but I think it's something that I need to tap back into. I kind of mostly use like my common sense for these questions. It's like 6, say here, 45 plus 20 minutes. That's going to give me 6 hours and 65 minutes. And already I know that this is 65 minutes is basically 60 minutes plus 5 minutes. It's kind of like what I'm thinking about. So that's 6 hours plus another hour, 60 minutes, make an hour. That's 7 and 05 minutes. So kind of common sense out that. I think that it would be 7:05. Okay, I definitely need to go back to some of my fundamental math where I remembered my teacher teaching how to calculate time. So it's something that I definitely need to look back on. Okay, all right guys, let's get into number 26 here. Which of the following could be the measure of the adjacent sides of a rectangle whose area is 60 squared centimeters? All right, so we know that the area of a rectangle, so we know that area of rec is equal to length multiplied by width, and we know that that's going to be 60 based on the question here. So we know that 30 times 30 is 900, so that can't be the answer. 20 times 40, that sounds like 800, so that could not be the answer. 15 times 15 is 225, so it sounds like 5 times 12. Okay, again, this really comes down to your ability to do the timetable here. So it's 5 and 12. 27. The exam score distribution for 200 students at a high school was 15, 35. C is unknown. Was there a diagram that represents this information here? I'm not sure. Not seen a diagram. The exam score distribution for 200 students at high school was... Not sure what this question is implying. Oh, okay. I think that 15% of the students got A's, 35% of the students got B, 30% got C, and 10% failed, pretty much. But we know that the distribution, total distribution is 100%, so it's going to be 100 minus the sum of these numbers here, 15 plus 35 plus X. Well, we're going to subtract whatever we get, so that's 35 plus 30 plus 10. So that's 100 minus 15 and 35, that's 40. 40 plus 30, that's 70. 70 plus 10 is 80. So I guess the answer is 20%. Okay, so here is 20%. All right, how many students scored C? Okay, so this is actually the information, and the calculation gives us the answer here. So 20 students, pretty much. It says how many students scored C. Okay, so 20% scored C, but we need to convert that 20%. It can be very tricky because if you have the 20% here, you might be tempted to circle 20 students. We've got to be careful. It's going to be 20% over 100 times 200. So cancel. So that's 20 times 2. That's 40 students. This should be correct. I'm not seeing the answer. I'm not seeing the answer, guys. The exam score distribution for 200 students at high school was 15, 35. So that's 50 plus 30. Okay, so it's okay. My apologies, guys. So I did make a mistake here. 15 plus 35 is 50 and not 40. So 15 plus 35 is 50. 50 plus 30 is 80. 80 plus 10 is 90. So the error here is actually, this is 90. So that obviously is going to be 10% here. And so this is going to be 10% here. and then that's 10 times 2, that's going to be 20 students. So the answer is in fact 20 students here. All right, so these things are going to happen in the exam. All right, and this is that mistake made by me there was as a result of me not understanding what the question was. As I said, this is the very first time that I'm actually seeing City and Guilds paper. The questions are pretty simple, but if you don't read carefully, you can misinterpret. 28. The table below shows times. The table below shows the times that an athlete ran 5 races of the same distance. So the first time he ran 9.38 seconds. He's faster than Usain Bolt. Well, we don't know what type of race it was, but it seems as if it's a 100-meter sprint. Could be a 50-meter dash. The second time he ran is 9.57. Okay, so he ran pretty fast, got a little slower, ran faster, ran slower, and was average out here at about 9.98. His 4th fastest time would be, well, it's just a matter of organizing these in order. So 4th fastest, let's start from the fastest time would have been here. This would have been the fastest time here, that's 1. Next fastest time would have been 2. The 3rd fastest time here would have been 3, and then the 4th fastest time would have been, say here, 9.98. So that's it, 9.98. Pretty easy. The table below shows the times in minutes that it took 35 students to solve a math problem. So time in minutes, 1, 2, 3, 4, 5, 6. Okay, so 1 student took 1 minute, 10 students took 2 minutes, 4 students took 3 minutes, nobody took 4 minutes, 2 students took 5 minutes, 7 students took 6 minutes, nobody took 7 minutes, 5 students took 8 minutes, 6 students took 9 minutes, and nobody took 10 minutes to complete the problem. How many students answered the question in less than 5 minutes? So less than 5 minutes, less than 5, we would have to pretty much part it here. Less than 5 minutes. We can't include 5 minutes. It says less than 5, so part it off here and count 1 plus 10 is 11 plus 4 is 15. So that's 15 students there. Alright, and you can notice that if you're not reading the question carefully, if you're not reading that it says less than 5, if you include the 5, you'll realize that the 17 is there to catch you. So you've got to read the question to see if it says less than 5 or up to 5 minutes. And finally, guys, we did a bit of extra bit of talking in this question. I may have missed. I think I left off the last question on the paper, guys, but not sure where that sheet went, but that pretty much completes the paper, guys. This paper was not a challenging one at that. Had a few tricky questions if you didn't read it properly, but for the most part the question was very doable. All right, so just this paper was done specifically for a student that had requested the help, Mr. Sean Colley. I do hope that this video was very useful to you, and I wish you all the best going forward into your exam coming up in June. I have a few more sample papers that I'm going to be doing, so look out for those. All right, so until next time, guys, take care. My name is Akin. My first City and Guilds paper, very interesting one at that. I like this paper. Questions are very doable, so hopefully you guys learned something from this. All right, so until then, take care. Bye bye.